It's 9:30 almost. Welcome to my talk. I know the title sounds very verbose. That's because that's the best thing that ChatGPT came up with, to be honest. What I really want us to talk about today is the instance metadata service. And if you're still deploying EC2 instances with IMDS v1, you need to go and fix that right away. That's really what we're talking about today. In case you're wondering if you're in the right room from maybe reading the abstract and you want to go through all the details, this is the abstract that I submitted for this talk. The important bits are that we'll talk about cloud workload identities. We'll do a demo using CloudGoat, similar to the bridge scenario for Capital One. And then hopefully I would also share some links and resources to help you if you have an IMDS v1 problem and you want to address that. Share some useful. Okay. Good.
Yeah. Everybody hear him okay?
Yeah.
Yeah.
Okay. Let's keep going.
No. It's just to keep moving away from. There you go. Changes.
I should understand.
It's okay. It's okay. Okay. Try talking now.
Okay.
Yeah.
Am I good?
Yeah.
Yeah. Okay. Let's keep going. Yeah. So in case you're wondering who I am, I go by Sam. My profile is up on the B-Sides website. Currently work as a security analyst for the company based out of Vancouver.
Sorry.
No worries. It's part of the phone. Should I try holding it? Yeah. Okay.
Yeah, you can try to hold.
All right. Okay. I think I'll keep it a bit further away. This sounds okay. Yeah. Okay. Cool. I've been a volunteer with B-Sides last year, and this is my second time volunteering, and this time decided to mix it up and give a talk. I have an MBA from the UFA. Now that the Oilers are really, really shit, it's easy for me to say go Flames. But Edmonton still has a fun place in my heart. Sorry to admit that. I have a few sets. As you can see, I like my InfoSec brew served cloudy. And I'm fully sipped into the InfoSec Kool-Aid. So you'll find out that I get 98% passion, maybe just 2% knowledge. Hopefully that's a useful 2%. In case you are here, you're in a hurry and you want the Cliff Notes version, we'll talk about IAM. I hope you already understand that IAM is probably the most important layer of control for cloud-hosted assets. There's a challenge when you're trying to configure resource-to-resource access, what in an on-prem world you would call a service account. IMDS is one solution. That way you can automate the process of getting temporary credentials for resource-to-resource access. But there are issues with the IMDS that you should be aware of, and you should look to be useful grounder to then explain machine identities. The challenge with machine identities, at some point we found our way meandering to start talking about IAM roles and EC2 instance profiles. We'll talk specifically about the IMDS v1, which is the problematic version of IMDS that you want to avoid using in your environment. We'll do a little AppSec because in addition to cloud infrastructure security, application security is like my other passion. We'll talk about what happens if you make a toxic brew of IMDS v1 and add a little sprinkling of SSRFs, and that's how you end up with data breaches. We will do a little demo with CloudGoat. It's an open source tool for learning pen testing of AWS environments. If you're a cloud person, you're not using CloudGoat already, please go use CloudGoat. It's fun. And it's an easy way to deploy really complicated infrastructure, which is single command, create or destroy. Really neat. Hopefully at the end of the day, I'll tell you what IMDS v2 and you and your cloud resources would live happily ever after. What I wanted us to do at this point is I have a little bit of a demo, like I said, with CloudGoat. Infrastructure takes like maybe 4 or 5 minutes to deploy. So I'll start the deployment now, switch back to the slides, and then hopefully at the point where we're ready to do the deployments, we'll have everything the demo, we'll have our infrastructure all good to go. So, okay, this worked. So if you were fast enough to point to the QR code that I had on the screen before I switched it over, maybe I should go back to showing. Okay, let's do the QR code on the screen. So, present. No. There you go. If you scan this QR code, you go to a Notion page that I have step-by-step instructions that I intend to mostly follow for the demo. So you could go there, look at the instructions. If you want to try this at home after today, you could do that as well. So hopefully you're seeing my terminal. I will move the mouse here. My step-by-step instruction really starts, I'm assuming like someone who doesn't have a lot of knowledge about the cloud, I needs to know I have an AWS account. What do I need to do to follow you? So I'm telling you what kind of user you should provision in your account, how to create access keys for those users. For today's conversation, I'm just going to skip over all of that and jump straight to where I'm cloning the repo for CloudGoat and actually setting things up. And I will prove to you that I've already configured a user in my AWS account with all of those credentials. If I just run this with a little bit of terminal completion magic, you see that I have an identity. If I call the STS service, I have an identity. That tells you that I have an AWS account configured on this on my CLI. So what I want to do here is let's clone the CloudGoat repository from GitHub. Well, quit here. There you go. Okay. Loading. Internet problems. Almost there. Okay. What I'm doing here is to create a Python virtual environment that I would use to install the dependencies that CloudGoat requires. Okay, I have my Python environment set up. What I want to do is to, no, I haven't added to source. Okay, thank you, terminal completion down there. And I want to pip install. Okay, almost there. I will say CloudGoat. Okay. I configure a profile on CloudGoat. I have a user called CloudGoat. From earlier when I showed the caller identity, so I tell it to use that profile, and I can say CloudGoat. Create. Yes, please. Okay, and I believe our deployment has started. We can switch back to the slides. Okay. So before I go any further, there are a few fundamental IAM concepts that I think we should all be speaking from the same page when we talk about those. If you point your QR code at that, your camera at that QR code, it takes you to a link to the reference that I have at the bottom. By the way, I do that for every slide where I have references at the bottom. I put the QR code just to make it easy to follow along. What is an identity? The folks at NIST provided this very extended definition, but I think it's easy to think of these things if you can connect it to human identity. So say you listening to me today, you want to set up a profile on Facebook. Maybe you go to Facebook, you provide an email address, a password, your date of birth, your address, your color of your underwear, your favorite meal, and all that stuff that Facebook asks for. You provide it for Facebook, and Facebook will say, okay, based on these attributes you provided, we know who you are, right? So that's identity. And then authentication is when you want to sign on to Facebook, you provide a subset of those attributes. So Facebook might say, give me your email address, your password, and hopefully something you have, a two-factor authentication code. You provide that, and they say, based on those subsets of your attributes you provided, comparing to our database, we know who you are, you're allowed to come in and use the Facebook system, right? Then authorization is about what you can do once you have access, once you've authenticated. So as a regular Facebook user, you might have the right to like upload pictures, watch other people's card videos, maybe post card videos of your own, right? And then accounting is about tying all of that together, being able to say who did what at any given point. Hopefully you have logs or some other system to use. Human identities in the cloud, you should probably be familiar with this. In the AWS context, you would have an IAM user. You would assign permission to either directly to that user, or you assign the user to a group that has some permission, and the user would inherit those permissions. User can interact with AWS resources by signing in either in the console or programmatically, like we're going to do for most of our demo today in the terminal. Okay, let's tie that to have your nice websites that you designed yourself. You set it up in the PHP server, and you spawn up an EC2 instance to host your website, right? And somewhere on your website, you provide the ability for people to upload cat photos. You need to store those cat photos somewhere. Maybe they can come back later and want to view the cat photos they have uploaded. Now you need to be able to read that data from somewhere. So it means that your application has an identity that it uses to read the data from wherever it is stored, right? So let's say your EC2 instance talks to S3 to store data, right? One way to do that is in your PHP application code. Somewhere in there, you can have a line that says AWS underscore secret access key. And then in the next line, AWS underscore access key to key. You have hard-coded credentials in the application code. And hopefully, as good security professionals, we know not to do that, because hard-coded credentials in applications is an anti-pattern. What AWS recommends that you do instead is to use an instance profile or a role. So that's how we're going to do it, right? Nice, security professionals. References provided here, you can scan the QR code to go look at it. So why is it worth specifically talking about machine identities? I grew up in the cloud, in IT, in the cloud world, so I don't really know that much about on-prem, but I know even on-prem service accounts was a problem. Now, what I think is that the cloud makes that problem a bit harder, because what you end up with is, for most application use cases, for instance, you'd have to orchestrate different services from a single cloud provider. So you have an EC2 instance somewhere, it needs to talk to S3, but there's IAM that you use for managing permissions to that instance, and maybe you're doing some AI stuff, you're using some other service. Every of that service is just an API call away, as opposed to on-prem where you could protect the service with firewalls and stuff. In AWS, everyththing is an API call. You can use some configurations to mimic those services running a private network, but at the most fundamental level, everything is an API call away. So it means you have multiple services that are just an API call away. How do you manage access between those services in the right way, right? It starts to, maybe it's easy enough to do if it's just you running your own website on a PHP server. But think of an enterprise that has an application that has maybe like 300 microservices. Multiply that by 10, you start to have a scaling problem. And you know, most things in life at scale start to become really difficult, right? So when you have cloud applications, you usually end up with a scenario where you have either a secret management problem, you're having credentials being hard-coded all over the place, or you have a least privilege problem as well. You are over provisioning resources with excessive functions. Sorry, I need to get this water. Okay. What are IAM rules? I told you what AWS recommends for you to do to use IAM rules. Well, what are IAM rules? something. Think of IAM rules in the same context. So you want an entity to have permission to resources, but you don't want to give that entity perpetual access. You create a role, you say you can assume that role, get elevated permissions, do whatever you want to do, and then after a while, those permissions will expire. What does that do for you? Well, it means that even if those permissions were somehow compromised, if someone got access to the authentication token for that session, after a fixed time duration, they become invalid. Except the attacker has some way of gaining continuous access to those tokens. It means that after the default expiry period, which I think by default in AWS is 12 hours for roles, of course, you can configure that to be even a bit as short as you want. So IAM rails are good. They give you access to temporary tokens that expire. That's good for security. Some example IAM roles, if you want your AWS account, even if you haven't configured anything, you see lots of AWS managed IAM roles. And I thought we would use one of those just for illustration, right? The specific example I've picked is the service role for API gateway. As with most resources on AWS, it's uniquely identified by an Amazon resource name. You'd have permissions and you'd also have a trust policy. And I'll talk in a minute about what the specific parts of this role mean. First off, there are three important things to keep in mind when you're thinking about IAM roles. So I said IAM roles are identities that can be assumed. The trust policy is what defines what can assume that identity. Otherwise, anybody in the cloud can assume a role into your account, right? So who can assume the role is a trust policy. I think it's useful to think about that as the authentication bit, right? And then once you assume the role, what can you do? That's the permission bit of an IAM role. So that has the authorization bit, right? So authentication, authorization. Back to this example, this is the trust policy attached to this AWS managed role. In case anyone here is not versed in the JSON policy language for AWS, what this is essentially saying is this API gateway service is allowed to assume this role. Simple, right? And then in terms of the permissions that are assigned to this role, again, looking at this console screenshot, the permissions itself is a policy. And if you dug into this policy, these are some of the subsets of permissions that it will grant you. So you see some elastic load balancer actions, you see an X-ray action, and some, I believe these are CloudWatch log permissions as well. So trust policy, permissions, those are the two useful bits to IAM roles, right? Easy, got it? Okay. So let's make that a bit more concrete. Let's go back to that application that we had running in an EC2 instance that needs access to S3. It would assume the role that gives it access to temporary tokens that it would use for that S3 access. This is what the trust policy would look like, right? It will say that the EC2 service is allowed to assume this role. Easy peasy. And then once it assumes the role, that entity is allowed to read objects from this bucket. Again, straightforward. So trust policy, permissions. How do you assign, if IAM roles are so great, how do we assign them to EC2 instances? We use what's known as an instance profile. I think about it as a wrapper around IAM roles. I haven't found a more useful analogy. It's basically an IAM role with some additional metadata. That's how I think about it. It would give you access to temporary tokens, just like we said you get with IAM roles. You can only assign one profile to an EC2 instance at a time. So let's make even that our example a bit more concrete. So I am the administrator of an AWS environment as a security person. I have to provision permissions for developers who want to build applications. I go in and I create a role that grants access to the bucket that has the cat pictures, right? And I say, Mr. Developer, if you want to build that application, please assume this instant profile get pics. It would allow you to get access to those photos. So developer writes the application wants to talk to this bucket. It goes and it retrieves credentials and it uses those credentials to fetch the cat photos, and we're all happy on the internet, right? So I glossed over a bit of the detail here. I said it would get credentials. Well, where is the getting GAD from? They're getting this got from the instance metadata service. I just made up that one. The instance metadata server, by default, on every EC2 instance that you launch in AWS, we'll be running a web server at 169.254.169.254. I like how that rhymes, makes it easy to remember. 169.254.169.254. That's because it's running on a linked local IP address. It should not be accessible outside of the EC2 instance. Linked local IP addresses are like 127.0.0.4. Should not be routable on your LAN, should not be routable on the internet. Azure and GCP also have the construct of instant metadata servers as well, but those are not quite as vulnerable as the IMDS in AWS is. So today we'll be talking about the AWS IMDS, not the Azure and GCP ones. So IMDS, back to our example, it's server running at 169.254.169.254. A line in your application code wants to go fetch cat photos to display to the user who's come to enjoy some lovely cat photos. The application will make a get request to this URL. So 169.254 latest, tag metadata, tag IAM, security credentials, / the name of the role, specific provision. The instance metadata server will return temporary credentials to the application. So it will be ASIA suffix access key IDs and then an access key secret. So if you see access key IDs that start with ASIA, those are temporary tokens, as opposed to AKIA access key IDs that are permanent, more permanent access key tokens. So it gets the credentials and then it uses the credentials to make calls to S3, fetches cat photos, and everyone is happy on the internet. You know how I said earlier, the instance metadata server by logic should not be accessible outside of the EC2 instance because it's running on the linked local IP addresses. Well, sometimes you might have a problem. That problem will be called a web application vulnerability. And if you have that problem, your instance metadata server might be accessible outside of EC2 instance. And one of those problems are called server-side request forgeries. Server-side request forgery is web application vulnerability, like I said. As with all web app vulns, I think untrusted user input and improper input sanitization is probably what you can point to as a what an SSRF vulnerability allows an attacker to do is to be able to make calls to backend services that you may not have intended for the web application to process requests and send back to the user. Sounds abstract. Let's make it more concrete. So say Mr. Attacker wants to get to a database server that I have running somewhere. As good security professional, we've configured these database credentials, really locked down security group rules and all that fun stuff. So the attacker is not able to get access to the server. But on our PHP server here, we have a server-side request forgery vulnerability. The attacker might be able to send requests to our web server and make those requests look like they're coming directly from the server. Because for reasons of business logic, we need to allow this web server to be able to talk to the database server, right? That's how applications run. We've allowed this. The attacker sends a request to web server server sends it to database, returns everything from select star back to the attacker, and now you have a data breach on your hands, right? SSRF's bad. If you don't remember any of that, bad. And John, just take my word for it. Evan Johnson, manager of product security at Cloudflare, just after the Capital One breach, also reemphasized that SSRFs and cloud are a very toxic thing. So what can we do? First off, a bit more explanation about SSRFs and why they make a toxic brew with the cloud. You have your application running in your EC2 instance, server-side request forgery vuln. Attacker will be able to make requests and talk to the IMDS server. IMDS returns temporary credentials to the attacker, and now the attacker has direct access to an S3 bucket that you've configured with people's maybe social insurance number, personal health data, all that stuff that you don't want attackers access to. Because your application needs to talk to that S3 server, it be provisioned with access. Now the attacker suddenly has access. So SSRFs plus cloud, bad. That's the summary of the slide. How bad can it get? Well, in 2019, Capital One got breached. I suspect everyone here would have heard this story by now. So A show of hands, who has not heard about the Capital One bridge? Brady's just being sarcastic. So everybody knows the Capital One bridge, 100 million records of credit card applicants in the US, 6 million in Canada. At some point, Capital One had to pay an $80 million fine, and $190 million to settle a class action lawsuit. I don't know about the place where you work, but where I work, this is a big chunk of change. And if we had to pay this kind of fines, I'm not sure I'll be continue to be employed. That my ability to keep being employed will be sustainable, right? So not good, not good. But the folks at Capital One, surprisingly, are actually quite good at security. So they were not being willfully negligent. If you go and search the open source community, there are lots of security tools. The one example that comes to mind is Cloud Custodian. I love Cloud Custodian. It was built by the folks at Capital. Right? So they knew what they were doing. It's just you had that toxic brew that somehow no one had anticipated and planned from. Hopefully, you'll be better prepared at the end of this conversation. Well, technical details of what happened was there's a mod security WAF appliance. You know what WAFs do? They filter requests going to backend application. The WAF was not properly configured, and it was basically not filtering for web requests potentially exploiting SSRFs. Application running on an EC2 instance had an SSRS vulnerability. This WAF was supposed to be protecting the application. Protection gone, attacker sends a request, hits the application, gets IMDS tokens that allowed access to an S3 bucket that was supposed to be protected. So it wasn't a case of S3 buckets, not permissions not be properly configured. It was not a publicly accessible S3. It was well protected. But because the application needed to talk to the S3 bucket, it had permissions. And by exploiting the SSRFs, now the attacker has just as much permission as the application to the S3 bucket. So again, I don't need to say what that means. That means you have a data breach on your hands, right? Like I said, overflogged example, everybody talks about SSRFs and IMDS. And I can guarantee in the first sentence, you're likely to hear Capital One. But that's just because when you have lawsuits, people have to talk, right? And when people talk, you get all the details. Lots of other organizations have been breached by similar scenario. We just don't have it in the public domain because there's been no lawsuits. I found links to resources from the folks at Unit 42 at Palo Alto Networks, and also this link that aggregates data breaches in the cloud. You find references to threat actors that are known to specifically try to use IMDS and SSRFs to exploit AWS environments, right? I also found links to two, what are those called? Bug bounties on HackerOne for exploitation of SSRF in the classic scenario. One was for Evernote, but a few more examples. If you want to see all this, is point out code or follow this URL if you're possible. If you're capable of following URLs with your eyes, that so it's almost time for the demo, but first I want to introduce CloudGoat. When I was submitting my RFP, the person I was thinking about attending this talk was someone newish to the cloud, trying to stumble their way through like I'm doing right now, and they're wanting ways to learn. One of the things you could use to learn about exploiting cloud applications is CloudGoat. I love CloudGoat because it abstracts away the complexity of deploying really complicated applications. So you might have an intentionally vulnerable application, like you say. And you have an application that pulls together pieces like using authentication with Cognito, running containers in Kubernetes. You don't need to know how to set up any of that. You just point a single command and CloudGoat, and it goes and deploys that stuff for you. And you can go hacking, and then when you're done, one single command, it tears it down. CloudGoat under the hood uses Terraform to deploy the application. So if you go learn a little bit of Terraform and you want to see how the cookies made, you can actually go in there and see the Terraform deployment templates. Well, you don't need to know Terraform to use CloudGoat. You just say CloudGoat creates, like you saw me do at the start of this demo, it creates it, and then when I'm done, I just run CloudGoat destroy and it destroys it. And if you want to know how to get to this thing that is better than sliced bread, in my opinion, you can follow this URL and then you get access to CloudGoat. I have to drink a lot of water because I'm yeah, just have to put that out here. So time for demo. If you haven't gone to this URL before, please point your cameras at that QR code, and you can just save it to look at it later. I promise there's no malware processed here. It's just a shortened URL to Notion page. So let's do the demo. Right. Am I out of time? Okay. Ooh, that was scary. I was going to say we haven't even started the fun part. So. Okay, struggle to find it. So let's do clear the screen. My apologies. I realize me doing this is not the most optimal way, but this is a volunteer conference, and this is how we're able to patch things together to get it to work after like an hour of troubleshooting this morning. So please bear with us. Thank you very much. I've already done all of these bits. I cloned the repo. I configured Cloud Boot. I set up a virtual environment. Done all of that fun stuff. It's just taking so long to render. We've already created the scenario as well. So what I want to do is look at the credentials from that scenario. I think I need to run. If I don't feel like running commands, I can just copy. Once upon a time, I was learning to be a developer. And someone told me that good developers write code and great developers copy. So I'm just going to be copying stuff. What I want to do, I want to split view. Arch. I'm going to the screen. Give me a second. Hopefully I can find it. If I can't, I will open up a note in VS Code. Okay. I'll get this nice knitted note here. Paste things into it. This is good. Paste. Okay. So we have those credentials, and assume that somehow you had an environment where improper security management, the developer committed code to GitHub, attacker scans GitHub, gets those credentials, and now they want to see what they have access to, right? So we the attacker who stood that we're about to configure the AWS CLI to and type. So what I'm just doing here, I'm configuring my AWS CLI, but I don't want it to use the default user. I want it to use a named user. I tell it to do that. It asks me for the access key ID, which I've already stolen here. In case anyone is in the audience and licking their lips at me showing credentials today, I spun up this AWS account a couple of days ago for this demo, and I'm going to tear it down as soon as I'm done. Thank you very much for not hacking my account. And I will skip through the rest of the details. Just use the default. Yes, it's one, right? Everybody uses yes, it's one. God, it. Okay, and I want JSON outputs, right? So what do I have access to as the attacker who just stole creds? I want to see profile. I told it to use the profile name CG underscore stat. So STS guest collide identity, I think of that as the Unix equivalent of who am I, right? You get access to an environment. You want to know what's your user ID, what's the name of AWS account. If you have access to call this API, you can get all of that detail. So I already know the accounts that I compromised. For example, I know the account ID from that number sequence. I know the username, the slash after the account ID in the Amazon resource names. So, yeah, actually, let's try that. So I want the fonts for the terminal. It sounds like something that should be viewed. Make text bigger. Better? Thanks, Brady. Okay. So what do I have access to after compromising this? Let's try doing this. Sorry, online folks. I hope you're still able to hear me. So attackers are after, at the end of the day, what attackers really want is data. All of that messing around with infrastructure is a way to get to the data. As an attacker, if I get into an environment and I can get to the data directly, I'm not even going to bother to explore any of the controls I have in the environment. So I'm a restless attacker. I'm in this account. I want to see if I have access to S3. Dang, access denied. Next thing I want to see is maybe they have misconfigured databases, right? Let's probe for CG start, CG start, RDS, describe database instances. Permission denied as well. So I don't have access to any data. What can I do, right? In reality, more attackers nowadays are not going to be doing all of this manually. They just point it to like Paku and enumerate, and right away they know what they have access to and they start trying to pivot. So I'm just doing this like a situation. That's not how it's done in the real world, but it's going to be a lot like faster and faster. So I don't have access to storage. Let's see if we can start at compute, right? So let's try Lambda functions. Yeah, those are quite popular nowadays in AWS environment. So let's see if we have access to Lambda list. So I can see right away that I have access to a Lambda function here. And whenever I'm running any AWS CLI action and I get results, it's always nice to just pipe it through JQ. You get a nice printed result, pretty printed results. And I can already see stuff that makes my eyes glow, right? Someone configured environment variables for this Lambda function with access tokens. As the attacker, I'm happy. I want people to do that, right? So let's paste these credentials and let's see what they give us access to. So let's call this Cloud Growth Lambda, right? I'm just stealing the name from when I practiced the demo earlier because I get that completion that way. In case you're wondering if I'm able to type that fast. Okay. Copy this, paste it. Copy this. Suspense. Okay. Defaults. So I go through those same sequence of actions, right? Access denied. I don't have permissions to data yet. So for my illustration said I was going to keep doing this and then get to the point, but let's just try to save some time because we might be running out of time soon. Do I need this yet? No, I don't think I need it. So I can minimize this out of the way and just do copy paste like good security professionals do, right? So yeah. Okay. So I've configured this user. Let's see what's up with the user. So get call identity. Reality, we already kind of skipped the step, but We see again, we see the AWS account, we see the username that was provisioned for this user that we've somehow managed to compromise. And then let's say for whatever reason, at some point, we decided to enumerate EC2 instances. So let's go here, copy and paste it. Okay, so what I essentially did was, if you follow the demo step by step, at some point I find out that I have an EC2 instance that is running a web server that has a public IP address. So I see an EC2 instance that has a public IP address. I filter for that public IP address and I make a request to that IP address to see what's running, and I get this response back from whatever is running in that EC2 instance. I can see right away that this must be a web server, like I'm getting HTML responses, right? That's how I know it's happening. And then, as pen testers, if you talk to any pen tester, they love error messages because error messages are what gives everything away. Pen testers, don't we all hate them? So if you pay attention to this error message, it's telling you URL must be a string. URL, what URL string? I didn't provide any. It says you provided undefined. So as an attacker, I would probably know to say, okay, maybe this needs a URL parameter to be input to it as well. And if I just go back to, let's go this. Let's go to the copy paste. Okay, so sorry, I'm doing the copy paste because of my typing scenario. So now I'm providing a URL as input to that request, right? And now it says, they have to make it obvious that they are trying to demo an SSRF in a web application. But it says, I want it to be useful. I tried to find google.com, but I couldn't. So what this tells you is obviously taking the input that I provide to it and somehow trying to fetch resources from that URL. And as an attacker in the cloud, once you see that, your eyes should light up because you know what to try next, right? If it has an SSRI vulnerability, I'm going straight to 169.254. What's in there? So this is what, if you go to the top level page for the IMDS server, this is what the response would look like. Those number sequences are for the various versions of the IMDS, and then if you always want to point to the latest one, you just go to /latest. So going to replay the previous command and go to /latest. Right? And yeah, I'm already getting all of that stuff that I should be expecting to get from the IMDS server. And specifically for the one that contains the rule that I want, I think this one. Paste this. Paste. Why is the internet so slow? So what should come back from this request is it would show the name of the role that was provisioned for this particular scenario. So it would be security credential / a particular role name. When CloudGo deploys the infrastructure for you, it names things according to a certain convention. So anything deployed with CloudGo to start with the CG, and then it might have, depending on the type of resource, it would have like a resource name prefix. So in this case, it's saying there's an EC2 role for SSRFs and then some random string at the end to ensure that if you are running CloudGoat and I'm running CloudGoat, if you use the same name, S3 resources, for example, cannot have name conflicts. The internet is slow. Ooh. Fun. What's a good demo without internet problems? Okay, maybe I should kill it and try to investigate. Oh, stupid. Yeah. Okay. Interesting. Am I not? I am. Oh, yeah. Oh. Okay. I guess we'll have to talk through it then. I did not plan for this, but let's give it one last try and see. I do have a backup though. Yeah, as one should do when they're doing a live demo. I made a little bit of a screen recording of me. So let's play the screen recording. I can just talk through it, right? Let's see. Yeah. Let's see. What am I doing here? So yes, just before I get the valid credentials from the first, so really close to where we started. Eventually, what I end up doing between that, let's go back here. So if the request to that had been successful in the live demo, you'd have seen an IAM role name that looks like this in the security credentials folder of the IMDS server. And if I call this URL with the name of the role, it returns temporary tokens back to me. And like I said, how do I know they are temporary tokens? You see that right here. The access key ID prefix starts with an ASIA. This is a security access key. And then in addition to that, when you call the IMDS through a role to get temporary tokens, you get an actual token as well. So access key ID, secret, and a token. Then to make API calls, you need the combination of those three, as opposed to just two that you need for permanent AKIA credentials. And what the token basically does, the token actually encodes any specific permissions that you have configured on that user. It encodes all of that. So that's how when you make API requests, they know to like match that to what permissions you should have access to when you assume that role. So explain. So what I'm doing here, I'm copying those credentials that I got from the IMDS server, I'm pasting it somewhere, then configuring my AWS CLI to use those credentials, right? Which is what you see me model through for the next little bit. Right, I'm exporting because they are temporary tokens, right? I don't want to configure those as users on my AWS CLI. So the other way you can configure the AWS CLI to use tokens is just set those tokens as environment variables, which is what I'm doing here. So rather than saying AWS configure a user, I'm just exporting those credentials that I get here. I export the access key ID, I export the access key secret, and then I'll eventually also I'll end up exporting the session token as well. Skip. 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 And see how long it takes me just to copy it and paste things in here. Yeah. Almost there. Okay. So now, 2 seconds back. Okay. Let me just show you through the rest of this. So what I want to show is after exporting all of those credentials, if I then make a get caller identity API call, I would also get reference in the result that would probably reveal to me that I'm assuming an IAM role as opposed to using long-term tokens. We're almost out of time, fun times. Maybe I'll just steal a few more minutes. Skip forward. Okay, so eventually what I find out is after I configure those credentials that I just stole from the IMDS server. Now I have access to S3 buckets in the account. And one particular S3 bucket here has been configured with, even as an attacker, like if I see something named secret in your environment, I know it's it's either something really good or it's something that I should totally avoid because it could be a honey token. But attack would probably go look at whatever is named secret, and I eventually find out that I have access to that S3 bucket. I can list what's inside of the S3 bucket. I see a token, a file called admin.txt. At that point, like your eyes would light up, right? If you're a pen tester. What the admin.txt credentials eventually gives you access to is you'll be able to call that original Lambda function from the beginning that we started, and that's how you capture the flag for the scenario. You end up happy and feel excited when you walk through that demo. So that's our demo. I think the summary of what the demo wanted to say, we can still kind of say it without walking through every step. And then eventually when I get home, I'm going to tear down this infrastructure. So back to our slides. Let's try to get through that as quickly as we can. This was the attack chain. Initial access via compromised credentials. We found Lambda environment variables. We compromised those, used that to find an EC2 instance, exploited an SSRI vulnerability. We got access to an S3 bucket. And you can think of as a security professional, different controls that you could have implemented at various stages to try to kill that attack chain. One of those controls could have been to like, do better AppSec for your application so that you don't end up with SSRFs, but proper management of the IMDS server would have also helped to mitigate that. And how you really manage that in reality is to use IMDS v2. I'm in a hurry trying to rush through these slides, but okay. The difference between IMDS v1 and IMDS v2, maybe that's the thing that I should just say that and end my talk, is that rather than just making straight GET requests to get those tokens, it does like an authentication bit. So it calls a particular endpoint, passing a header that says how long it wants your credentials to be valid for. It gets the token back, and then it uses that token to make requests to actually get the credentials that will be able to access resources. And what that essentially does for you is you cannot exploit an open WAF because most open WAFs don't support put requests. So that first request here is not a GET request, it's a put request. And also, it's when it gives the response, you can set a hop limit on the response that you get. So if you set a TTL equal to 1, any packets that are coming back from the IMDS server cannot flow beyond the EC2 instance. And then the IMDS server for version 2 would also drop any packet that has an X forwarded for header. And if you are using a reverse proxy in front of a web application, it would always append an X forwarded for header because that's how it knows which original client sent it that request. So by using IMDS v1, the v2 essentially, you kind of help to mitigate that SSRF plus IMDS vulnerability that we're going to exploit in this demo. So, and that's why you should use IMDS v2 and not use IMDS v1. That's the summary of what the rest of the slides we're going to say. I will make the slides available so you can refer to that content. It walks you through if you're provisioning instances with AWS CloudFormation, Terraform, or even from the EC2 console, how to ensure that you are launching those instances with just IMDS v2 and not accidentally IMDS v1. I also show how to use the service control policy to actually make it impossible for developers to launch instances with IMDS v1 in the first instance. And I think AWS just announced a couple of weeks ago that they'll change the default for EC2 instances from sometime next year to be IMDS v2. Hopefully that helps to mitigate this scenario because people like defaults, and if you give them unsafe default, most times they just leave it because if it works, why mess with it, right? So, that's my talk. Hopefully we're able to have fun despite the technology problem.